So we are now in chapter 4, values and types. So in this chapter, at first you need to know about token. So what is token in Java? A token, I'm writing the definition here. Each individual component of a Java statement that carries a specific meaning and takes part in effective execution of the program is known as token. Okay, and Java programming uses various types of token. These are: number 1, literals; number 2, identifiers; number 3, assignment; number 4, keywords; number 5, operators; number 6, punctuators; and number 7, separators. So these are the 7 tokens are used in Java programming. So out of these tokens, at first we have to know in detail about literal. Okay, so what do you mean by literals? So another name of literals is constant. A literal is also known as constant. So I'm writing the definition. These are the quantities. These are the quantities that remain fixed. Throughout the discussion of the program. Okay, that means the values will not be changed. These values will remain fixed throughout the discussion of the program. Now we will discuss about the various types of literals that are used in Java programming. So literals are how many types? Number 1 is integer literals. Number 2 is floating point or real literals. Number 3 is character literals. Number 4, string literal. Number 5, Boolean literal. And another one is null literal. NULL. Okay. So integer literal, real literal, character literal, string literal, Boolean literal, and null literal. These literals are used in Java programming. So at first we will know about integer literal in detail. Okay. So what is integer literal? You must note down the important points in your school copy. Okay. So what do you mean by integer literals? So integer literals are the whole numbers without any fractional part. Okay, without any fractional part. Now some points about integer literals are: an integer constant or integer literal must have one digit and must not contain any decimal point. That means if I write 12.3, then it is not an integer, it is not an integer literal, because here decimal point is given. So integer literal must have one digit. Like suppose 2. 2 is an integer literal. Okay. And it should not contain, it must not contain any decimal point. So there is no decimal point in integer literal. Okay. Number 2, an integer literal may contain either plus or minus sign. An integer with no sign is assumed to be positive. You already know this. If I write 13, so 13 is a positive number or a negative number? 13 is a positive number because there is no sign that precedes this digit, this number. That's why 13 is a positive number. But if I write a minus 13, then we will say that 13 is a negative number and we will say minus 13. Is that clear? Okay. And another thing, that generally we used to write any big integer by using comma, just like 10,000. So these are in daily life. We used to do this, isn't it? But in Java we cannot write like this. That means in Java commas are not allowed. So in Java programming, if I want to write 10,000, then I have to write after 1 4 zeros, but without any comma. Is that clear? Okay. Now integer literals. Integer literals are of three types. That means three types of integer literals are used in Java program. Here we are discussing the types regarding Java program only. Okay. So integer literals, there are three types of integer literals used in Java programming. Number one is decimal integer literal. Decimal integer literal. Number two is octal integer literal. And number three is hexadecimal integer literal. Okay. So these three: decimal, octal and hexadecimal. Is that clear? Now you already know the base of decimal number system is 10, because decimal number system is composed of 10 digits, 0 to 9. The base of octal number system is how much? 8. 0 to 7. And base of hexadecimal number is 16. 0 to 9 and A to F. Isn't it? Okay. So at first, decimal integer literal. So we need to know about decimal integer literal. So in decimal integer literal, I can say that an integer literal consisting of a sequence of digits is taken to decimal integer literal unless it begins with 0. I am telling again, an integer literal consisting of a sequence of digits An integer literal consisting of a sequence of digits is taken to be a decimal integer unless it begins with 0. That means decimal integers, we cannot write 0 at the beginning. That means I cannot write 013. Though 0 is a decimal digit, but still I cannot write 0 at the beginning of this 13. Oh, I have to write 13. Okay, so digit 0 cannot precede the integer value. Remember this one. Okay. Example. Some examples of decimal integer literal. 197. I can also write plus 197, no problem. I can write minus 83. Another example, suppose 1381. So these are the examples of decimal integer literals. So what is the characteristic? Decimal integer literal must not begin with digit 0. Okay. Now number 2, octal. So what happens in case of octal number system? Octal numbers, a sequence of digits, I am telling the definition, a sequence of digits starting with 0 is taken to be an octal integer in Java programming. So any number, but you have to remember that the sequence must not contain 8 and 9. The sequence must not contain 8 and 9. Why? Because 8 and 9 are invalid octal digits. As you know, in octal number system only 0 to 7 digits are allowed. Only 8 digits are allowed. That's why 8 and 9, they are not allowed. So octal number is represented with 0 at the beginning, isn't it? So suppose for an example, if I write 8 in decimal number system, what is the value of 8 in octal number system? It is 10. Isn't it? How? 8 in decimals are divided by 8, division process. So 8 ones are 8, remainder 0. And no other division is possible. That's why this is the most significant digit and this is the least significant digit, 10. So 10 in octal. So if I want to write 8, the decimal number 8 in octal number system, then I have to write 010 in Java programming. So 010, that means it is an octal number. Similarly, if I want to write 15 in decimal, that means 15 in octal number, the decimal number 15 in octal number, then 15 is equivalent to 17 in octal number system. That's why I have to write 017 in Java to represent 15. So 15 is represented as octal number and that should be written as 017. So 017, that means you have to think that 17 is octal number and its equivalent decimal number is 15. Okay, so these are the octal numbers. And now the hexadecimal number. Hexadecimal number system base is 16. So the definition is a sequence of digits preceded by 0 x, 0 small x or 0 capital X is taken to be an hexadecimal integer. Just like octal number is represented by 0, then an integer, just like 010, that means 010, that means actually 8. Similarly, in any decimal number is represented in hexadecimal form which is preceded by 0x. So x can be small letter, x can be capital letter. For example, consider the decimal number 12. So 12 in hexadecimal is C. You already know because hexadecimal number system contains the decimal digits 0 to 9, and then after 10, after that 10 to 15, A, B, C, D, E and F. A means 10, B means 11, C means 12, D means 13, E means 14 and F means 15. So 0 to 15, total 16 digits. That's why the base of hexadecimal number system is 16. So 12 in decimal means C in hexadecimal. So it should be written like 0xC. 0x will be written as per the convention and then C. So 0xC will be written to represent the decimal number 12 as hexadecimal number system in Java programming. Is that clear? Similarly, 15. How will represent the decimal number 15 as hexadecimal number system in Java? 0xf, because 15 means f, so we have to write 0xf. So before every hexadecimal number we need to write 0xf. As before every octal number we need to write 0. Similarly, we need to write 0x for every hexadecimal number in Java programming. Is that clear? Now we will discuss about the second literal, that is real literal. Real literal. So what are real literal? Real literal are also known as floating literals. Okay, and these are the numbers with fractional part. So in integer literal there was no fractional part, but in real literals there is a fractional part. So a real literal must contain a fractional part. That means there will be a decimal point. Now what is the important thing about this real literal, that you need to know about two things. These real literals are represented in two possible forms, in two forms. Number one is standard form or fractional form. There are two names, standard form or fractional form, and second one is scientific form or exponent form. Okay, so at first the standard form. Now the standard form, a real literal in standard form must have, listen carefully, a real literal in standard form must have at least one digit before the decimal point and after the decimal point. Okay, so there may be more than one digit, but at least one digit must appear before and after the decimal point. That is the first criteria. Now a standard form, real literal in standard form may also have plus or minus sign preceding it. So plus sign can precede the standard form of real literal, and minus sign can also precede the standard form of real literal. And a real literal with no sign, just like this one, a real literal with no sign is assumed to be positive number. Is that clear? So if I write 3.8, it will be regarded as a positive number. If I write plus 3.8, it will also be regarded as a positive number. But if I write minus 2.3, it will be regarded as a negative number. And another thing is that commas cannot appear. Just like integer literals, commas cannot appear in real literals, in a standard form of real literals. Just like if I write 17,206.83, so it is a fractional, though it is a fractional number which is used in solving the problem of mathematics, but in Java programming this comma is not allowed. We have to write 17,206 without any comma, 0.83. So this is valid and this is invalid format. Okay, now we will discuss about the scientific form. the scientific form of real literals. So the scientific form of real literal is consists of two parts. Number one is mantissa. Okay, let me write at first. Scientific form. Okay, so scientific form consists of two parts. Number one is mantissa and the second one is exponent. So if I write, suppose take one real literal in standard form, that is 5.8. So 5.8 can be represented as 0.58 into 10 to the power 1. I can write it. That means it can also be represented as 0.58 then e then 1. So now which part is known as mantissa and which part is known as exponent here? As you can see here, we will consider this one. The part of the scientific form that appears before e is known as mantissa. That means this part appears before e is known as mantissa. Okay, and the part that appears after e is known as exponent. So this one is exponent. So the part that appears before e is known as mantissa and the part that appears after e is known as exponent. Here E1 means actually 10 to the power 1. So if I write E10, that means 10 to the power 10. If I write E minus 3, that means 10 to the power minus 3. Okay. So this mantissa, the mantissa must be either an integer, the mantissa may be an integer or a proper real literal. The mantissa is followed by the letter E. This letter E can be small or capital. So the mantissa that is followed by small e or capital E and the exponent. And as you can see, this exponent must be an integer. So now if I write one number 182.E8, can you say that it is a valid or invalid scientific form of real literal? 182.E8. Obviously this is invalid because at least one digit must appear after the decimal point. So as you can see, after the decimal point there is no digit. After the decimal point E is written. So it is invalid. If I write 7.8 E, this is valid or invalid? This is also invalid because no digit is written for exponent. So after the E, one digit must be written. One or more digits must be written to express the exponent. So 7.8 E is actually invalid. Okay, so in this way you have to recognize that which standard form is valid, which standard form is invalid, which scientific form is valid, which scientific form is invalid. So this type of questions may be given in exam. Now character literal. The definition of character literal is, it is a single character enclosed within single quotes. Okay. For example, capital A within single quote, small a within single quote, digit 4 within single quote, percentage sign within single quote, etc. So these are the examples of character literals. Okay. So now, one thing you must remember, that these characters are graphic characters. Graphic characters means these characters can be directly typed from the keyboard. But there are some other characters that cannot be typed directly from the keyboard, and those characters are known as non-graphic characters. Non-graphic characters. Okay, non-graphic characters. So Java allows us to have certain non-graphic characters in character literals. So these are also character literals. Now, what is the example of some non-graphic characters? Non-graphic character example are backspace, tab, new line feed. That means to change the line, new line feed. Okay, so these are the examples of some non-graphic characters. So how these characters are represented? So these non-graphic characters are represented by escape sequence. Escape sequence. Okay. So these non-graphic characters are represented by escape sequence. So what is escape sequence? I am writing the definition. It is a combination of backslash, that means this sign, followed by one or more characters. That means after the backslash there may be one character or maybe more than one character. So one or more characters and are used in Java programming to control the cursor's movement, on the screen, or to allow the users to customize the screen and get a formatted output. Okay. So this is the definition of escape sequence. For examples, backslash b represents backspace. So to effect the working of backspace, backslash b is typed in Java programming. To move the cursor to the next line, backslash n is used. That is new line feed. And to use the function of tab, we use backslash t. That is tab. So these are some examples of escape sequences. Is that clear? Now we will learn about string literals. String literals, what is the definition? It is a sequence of 0 or more characters. 0 or more characters within double quotes. So remember, character literals are enclosed within single quote and string literals are enclosed within double quotes. Okay. For examples, if I write lion enclosed within double quotes, then lion is a string. Write southern school enclosed within double quotation, and southern school is also an example of string, etc. Okay. And here in this definition you can see that it is a sequence of 0 or more characters. So these are the sequence of more characters, more than 0 characters. So what do you mean by it is a sequence of 0 characters? That means inside the double quotation, if nothing is written, that means there is no character inside this double quotation. This string, this is also a string. This string is known as null string. So inside the double quotation, if nothing is written, not even space, if nothing is written, then the string is known as null string. Okay. Now our next literal is Boolean literal. Boolean literals. So Boolean literals represent two values. Number one is true and another one is false. So true and false are together called Boolean literals. These two literals are used in Java programs to check whether a given logical condition is satisfied or not. If the logical condition is satisfied, then true is returned, otherwise false will be returned. Okay, so Boolean literals are only the two constant values. They are true and false. Okay, which are used in Java program to check whether a given condition is satisfied or not. Next one is null literal. Null literal, it is a special purpose literal. Since it is also a special purpose literal like Boolean literal, used in Java programs as a string terminator. So null literal is used as a string terminator. Remember this one, as a string terminator to mark the end of a string. So to mark the end of a string, null literal is used as a string terminator, and it is represented as within single quote backslash then 0. That is null literal. Okay, so that's all for now.